Here we have a question. Given B bar is equal to 10y ax cap minus 5x ay cap milliweber per meter square in a material whose relative permeability is 2.5. Find the current density. So we know what is the expression for current density. It is J bar is equal to del cross H bar. Okay, but here H bar is not given, B bar is given, but we can write H bar in terms of B bar, right? So del cross B bar by mu. Okay, so this is going to be del cross something is the curl of that vector. Okay, so that is going to be Ax cap, Ay cap, Az cap, dou by dou x, dou by dou y, dou by dou z, and in the last row there will be components of B bar by mu. Okay, by mu should not forget here. So Ax component is 10y by mu minus 5x by mu, and there is no z component, so it is 0. Okay, so this is going to be Ax cap 0 minus 0, because here dou by dou z of this function, right? So there is no z component here, so it will simply be 0. So there is no Ax component. Okay, minus Ay cap 0 minus 0 once again, because here there is 0, and dou by dou z of this will be 0 because there is no z component here. Okay, and then finally you have the Az cap dou by dou x of minus 5x by mu minus dou by dou y of 10y by mu. So this you are going to get minus 5 by mu minus 10 by mu Ax cap. Okay, you can write into 10 to the power minus 3 because the H bar is given in milliweber per meter square. You can include the same thing here as well. Okay, so here you are going to get into 10 to the power minus 3 into 10 to the power minus 3. Okay, and here you can include here. Okay, so this is the expression. Now if we substitute, we know the value of mu, right? Mu is given as here mu is equal to mu r into mu naught. Mu r is given as 2.5. So 2.5 into mu naught is 4 pi into 10 to the power minus 7. Okay, so if you substitute this answer, you are going to get J bar is equal to 4.77 Az cap kilo ampere per meter square. The xy plane serves as the interface between two different media. Medium 1, which is in the region z less than 0, is filled with a material whose mu r is equal to 6, and medium 2, z greater than 0, is filled with a material whose mu r is equal to 4. If the interface carries a current 1 by mu naught Ay cap milliampere per meter and B2 bar is equal to 5 Ax cap plus 8 Az cap milliweber per meter square, find H1 bar and B1 bar. Here what is given? The xy plane, let's say this is the xy plane, this is the acting as the boundary between two regions. Okay, so for z less than 0, there is a medium 1. So let z less than 0 is, this will be the z axis, right? So z less than 0 is the bottom part. So you are going to have here, this is the region 1. Okay, and what is the relative permeability that is given here? Mu r1 is equal to 6. Okay, and above the interface, above the boundary, the medium is 2. And what is the given relative permeability? It is given as 4. Mu r2 is 4. Now what other information is given here? It is saying that there is a surface current of 1 by mu naught Ay cap milliampere per meter. Okay, and the magnetic field in the second region is given 5 Ax cap plus 8 Az cap. This is also in milliweber per meter square. If you want, you can convert into 10 to the power minus 3, but since both of them they are in milli, we don't have to use 10 to the power minus 3, but units you should keep in this units, milliampere per meter and milliweber per meter square. Okay, so what are the two boundary conditions that we have? The first one is that B1 n bar is equal to B2 n bar, and the second one is H1 bar minus H2 bar cross A N12 cap, or you can take bar. This is equal to the surface current, okay, K bar. So these are the two equations from which we have to find out H1 bar and B1 bar. Now the z axis is like this, right? This is the z axis because this is the xy plane, okay. So in this B2 bar, what will be the normal component? The component which is parallel to the z axis, which is 8az cap, okay. So first step what we have to do, the first step is to find the tangential and normal components, okay. So B2n, here we have B2 given, so B2n bar is equal to 8az cap, okay, and B2t bar will be the remaining part, whatever is remaining. Here only the x component is remaining, but if there is a y component as well, that will also be included, okay. So first we have found out the normal and the tangential components. Then we can apply the first equation. What is that? B1 n bar is equal to B2 n bar. So this will be equal to 8 az cap. So B1 n bar we know, okay. We also need, we want H1 bar as well as B1 bar, okay. So we can write H1 n bar, this will be what? B1 n bar divided by mu 1, okay. So this is going to be B1 n bar, we found out 8 az cap divided by mu r1, which is 6 into mu naught. Now we will find the tangential part, okay. So for that we will use the second equation. So this is going to be H1 bar, we have to write in terms of B1 bar because we know B1 bar by mu 1 minus B2 bar by mu 2 cross A N12 bar is equal to K bar, okay. So now B1 bar we don't know, so we will just write it as it is, and mu 1 is nothing but 6 mu naught, okay, minus B2 bar is given, what is it? 5 ax cap plus 8 az cap divided by mu 2 is mu r2 into mu naught. So mu r2 is given as 4 into mu naught cross A N12 cap, okay. So if you see here, what is the normal direction? It should be from the region 1 to region 2, okay. So from this to this, so what will be the normal vector? It will be in this direction, A N12 cap. So this is equal to az cap because it is in the direction of positive z axis. So here we substitute az cap, and this is equal to k bar is given as 1 by mu naught ay cap, okay. So here you can see mu naught will get cancelled, okay, all the mu naught will get cancelled. Now this, if you expand, you can write as B1 bar by 6 cross az cap, okay, minus 5 by 4 ax cap cross az cap is going to be minus ay cap minus 8 by 4 az cap cross az cap is 0, right, parallel vectors are 0. So this is going to be ay cap. So from here you are going to get B1 bar by 6 cross az cap, this is going to be equal to 1 minus 5 by 4 ay cap, okay. So from here what do you see? See, only this cross product should give you a result in the ay component only, okay. So that means B1 bar, the x component of B1 bar will only contribute to the cross product. The other terms, even if they are there, it is going to be 0, okay. So that means B1 bar can have x and z components, it cannot have y component. Why? If there is a y component, then the resultant should also have some ax component because y cross z is x, okay. Because there is only ay component, B1 bar should be having only x and z components. So here we can write B1x ax cap plus B1z az cap divided by 6 is equal to minus 1 by 4 ay cap, okay. So from here you are going to get B1x is equal to 1.5. Okay, so from here you can get, therefore, the tangential component, right? This is only the tangential component, so this is going to be 1.5 ax cap. Okay, so we have the tangential component now. So now we have the tangential as well as the normal components. So we can write B1 bar is equal to B1 T bar plus B1 N bar, and this is equal to 1.5 ax cap plus 8 az cap. What is the units here? Milliweber per meter square. Okay, and what about H1 bar? This is going to be B1 bar by mu1. Okay, so here you can write 1.5 ax cap plus 8 az cap divided by 6 mu naught. Okay, so here you can write 0.25 ax cap plus 1.33 az cap divided by mu naught.